6.1 Sequences and Binomial Expansion. Well, you may not know it, but you've dealt with sequences before. A sequence is just an ordered list of numbers. It's basically just a pattern of numbers. And we're trying to figure out what the pattern is. And each term in that sequence, well, each number, each item in that sequence is called a term. And you reference them by their position. So when you're looking at, like in this first one here, 32 is the first term. So if we called this one, you'd say a sub 1 is 32. And then a sub 2 is 16. That's the second term in the sequence. And then a sub 3 is 8. And they can use different letters than a, but a is just the common one. So that's kind of why I use that one. So that's what the terms are. And there is a way to come up with the nth term, but we're going to come up with that in a future lesson. So let's see. Anything else I need to tell you about? No, I think we're ready to dive on in. So look at this first one. It says find the next 4 terms in this sequence. So what we need to do is figure out what is the pattern. So we have 32, then 16. Well, my first instinct was we would subtract 16, but then we go 16 to 8. Subtracting 16 doesn't work, so that's not the same pattern. So is there something that we see that's the same? To get from 32 to 16 to 8 to 4. Well, we can divide by 2. 32 divided by 2 gets you to 16. 16 divided by 2 gets you to 8. 8 divided by 2 gets you to 4. So the next one in the pattern, we have to take 4 divided by 2, which will be 2. Then to get the next one, we do 2 divided by 2, which is 1. And if we divide again, 1 divided by 2 is 1/2. And then 1/2 divided by 2 is 1/4. And those are the next 4 terms in that pattern, in that sequence. Number 2, find the next 4 terms in this sequence. Well, look, from 1 to 2, we can multiply by 2. 2 to 4, we can multiply by 2, so that's still working. 4 to 7, we can't multiply by 2, so it's not multiplying by anything on this pattern. So I look, what's the difference? The difference from 1 to 2, that went up by 1. 2 to 4 went up by 2. Well, that's not the same, but let's continue. 4 to 7 went up by 3. 7 to 11 went up by 4. 11 to 16 went up by 5. I think I see a pattern here. And 16 to 22 went up by 6. So to get the next one, I'm going to go up by 7. 22 plus 7 is 29, so that'll be the next one. After that, we're going to go up by 8. So 29 plus 8 is 37. And now we go up by 9, so add 9 to that, and you get 46. And then we go up by 10, so 56. And now we have it in a formula version. So find the first 4 terms. Well, the first term, so a sub 1, 1 would be the first term, is what n represents for the first term in the sequence, would be 2 times 1 times negative 1 to the first power. Negative 1 to the first power is negative 1 times 2 is negative 2. Well, the next term, a sub 2, the second term in this pattern, is 2 times n. N is our second term, so we're going to put a 2 there. And then negative 1 to the nth, and n was 2 again. So now negative 1 squared is positive 1, so that's 2 times 1, which is positive 4. And then the third term in this pattern, we have 2 times whatever n is, which n is 3 this time, and then negative 1 to the nth term, to the third power. Negative 1 to the third is negative 1 times negative 1 times negative 1, which will be negative. And 2 times 3 is 6, so it's negative 6. So if you kind of look at this pattern, it's 2, 4, 6. We're multiplying by 2 each time, and it's just changing signs. So the next one is 2 times n, which is now 4, times negative 1 to the 4th power. Well, negative 1 to the 4th is positive, so that's 2 times 4 is 8. And there are the first 4 terms in this pattern. If we want to write just the terms, it'd be negative 2, positive 4, negative 6, and positive 8. So, let's see. The next tip of advice I need to tell you about, sequences can be defined recursively. Well, a recursive pattern is just one where the way you come up with the next term in the pattern is based on the previous term. And you need at least 2 pieces of information on this. Usually you have to have a term to start with and a formula on how to get to the next term. And that's what this is going to look at on number 4. It says find the 5th term of the recursive sequence when they tell us the first term is 1, and then any term, a sub n, which stands for any term, is equal to the previous term. A sub n minus 1 means the term before that, plus 2 times whatever n is minus 1. Well, we can't use that pattern until after we get to 2. But we know the first term. A sub 1 is the first term, and the first term is 1. So to get the second term in the pattern, a sub 2 is going to be a sub 2 minus 1, or a sub 1, which is the previous term that we had, plus 2 times what n is, and n was 2, so 2 times 2 minus 1. So in this case, a sub 1 we just said was 1, and then 2 times 2 is 4, so 1 plus 4 minus 1 is 4. Well, to get the third term, our goal is to get to the fifth term, and we have to work our way all the way up to it. So to get the third term, we have to take the second term plus 2 times 3 minus 1. The n was 3. And so the second term, we go back and look at what a sub 2 was, which was 4, plus 2 times 3 is 6 minus 1. That's 10 minus 1. That's 9. And we're going to do that 2 more times. So now to get the fourth term, I'm going to take the third term plus 2 times n is 4, and then minus 1. The third term was 9, and then we had plus 8 minus 1, which is 17 minus 1 is 16. And so what we're trying to get to is the fifth term, so I have to take the fourth term plus 2 times what n was, which is 5, and then minus 1. So the fourth term was 16, plus 10 minus 1 is 26 minus 1 is 25. So the fifth term in this pattern is 25. Well, number 5 wants us to do the same thing. It says find the sixth term. So we're going to go all the way down to the sixth row. Well, you can't just plug in 6. If I try to find the sixth term, a sub 6 is going to be negative 2 times a to the fifth, or a sub 5, which means the fifth term in the pattern. And I don't know the fifth term, so we have to work our way back up to it. So you can't just start straight with what you're looking for. So we have to start with the first term, and the first term was 3. Then the second term is going to be negative 2 times a sub n minus 1, which means the previous term. So a sub 2 minus 1 is 1. So it is just negative 2 times what our previous term was, which was 3. So that's negative 6. So a sub 3 is negative 2 times what a was, or a sub n minus 1 would be a sub 2, which a sub 2 is negative 6. So it's negative 2 times negative 6, which would be 12. And hopefully you can follow this pattern. A sub 4 is going to be negative 2 times the previous term, which was a sub 3, which we just saw a sub 3 was 12. So that's negative 24. And if you notice this pattern, it started with 3, then it was negative 6, 12, negative 24. Looks like we're doubling and changing signs. The fifth term is going to be negative 2 times the fourth term, which is negative 2 times negative 24, which is 48. And then the sixth term in this pattern is negative 2 times the fifth term, which is negative 2 times 48, which is negative 96. Now, some new terminology that you may have seen before many, many years ago, I think taught in middle school, but it's been a long time, is if you ever see an exclamation mark, that's not an emphasis. We're not trying to shout in. We're actually trying to use a math term, which means you take that number times the next number below it, times the next number below it, times the next number below it, until you get all the way down to 1. Like in this example, 4 factorial means 4 times the number below it is 3, times the number below it's 2, 4 times 3 times 2 times 1. So on our example number 6 here, the first one, 6 factorial means 6 times 5 times 4 times 3 times 2 times 1. And then we just had to multiply that out. 6 times 5 is 30. 30 times 4 is 120. 120 times 3 times 2 times 1 is 6. 100, I can do that in my head. Is 120 times 6 is 720. I did hear a story one time about a student who during a test saw the factorials in SAT and they thought, why is it shouting 6? But it's not a shouting. It just means multiply by the numbers below it. If you see it written as a fraction, well, we start, look at 12 as a factorial. It would be 12 times 11 times 10 times 9 times 8, and keep going down. Well, 10 factorial is 10 times 9 times 8 and all the way down. Well, we could have just left that. If you notice, this from right here on is still 10 factorial. Whoops, that didn't mean to leave a trail on my pen. 10 factorial, and this was 10 factorial, and it's all multiplication, so you can divide out that whole 10 factorial. So what we have is 12 times 11 times, since there's a 10 factorial in the denominator, I'm going to leave that one 10 factorial, and then I'm going to have that over 10 factorial, and I'm going to divide those out. So to answer this one, it's just 12 times 11, which is 132. And on the last one, on number 6, n plus 1 factorial means we're taking n plus 1. Well, the term that comes after that is you subtract 1. N plus 1 minus 1 is just n. And then if we needed to keep going, that'd be n minus 1 and n minus 2 and so forth. But I'm going to leave that as n factorial because look at the denominator. Now I have an n factorial, and both the numerator and the denominator can divide that out. So we're left with just n plus 1 is the answer. So on the back, we're going to talk about some expanding binomials. So, well, let's just do a little math here to kind of build up to where we're headed. Anything to the 0 power is 1. And if we're talking about what coefficients you see, well, there's only one coefficient there, that's a 1. Well, a plus b to the first is just a plus b. So we look at that coefficient and that coefficient, and that's a 1 and a 1. And I know I'm kind of writing it all centered like that, and it'll make more. If you look down, you can kind of see where we're headed. But if we do a plus b squared, quantity squared, well, that's a plus b times a plus b, which is going to be a squared, plus ab plus another ab, so plus 2ab, oops, and then plus b squared. So if we look at just the coefficients, that's 1, 2, 1. 1, 2, 1. Well, maybe somewhere along your career, you've seen this expression exposed to you before, where if you notice these numbers, we have 1, 1, 1, 1, 2, 1. Well, if that pattern continues, you have 1, 3, 3, 1. That's called Pascal's triangle. And every row can be found, the new row below it can be found by adding the two numbers above it. So like the next row, this would be a 1. 1 plus 2 is 3. 2 plus 1 is 3. And then the outer numbers always just continue down. But the middle ones are always the sum of the row above, of the two numbers above it. Well, we gave you the first 6 rows. Well, actually, the first 1, 2, 3, 4, 5, 6, 7 rows, because they call row 0 because it matches up with the powers. This matches up with the coefficients for when you're expanding a binomial. So if we consider the first row row 0, that's anything to the 0 power is just 1, and then the second row would be to the first power, and then the third row, we call it the second row because remember we started with row 0. So if you keep that in mind, that the first row is 0, every row is going to match up with the expanded form of a binomial. So the steps to do this problem, you can actually, instead of trying, if I gave you a really huge number like a plus b to the 5th, instead of trying to do a plus b times a plus b times a plus b, doing this 5 times, which would not be fun at all. It's doable, but not pleasant. There's 4. You'd have to multiply these two, and then do it and multiply those together, and then finally multiply by another a plus b. There's a faster way. The coefficients will always come from Pascal's triangle. So for the 5th row, we look at the 5th row. And the coefficients are going to come from 1, 5, 10, 10, 5, and 1. Those are separate terms. So the first term will have a 1, and I'm going to try to leave a space here, and then I'll talk about how to fill in the rest of it. The next term has a 5. And then we have 10, 10, 10, 10. I can't write too bad because I'll go into my, and 5 and 1. So I didn't leave a whole lot of room. But now, the way you get the other values, you start with the first term. And we're going to write that term to the 5th power because we started at power 5, a to the 5th. And then it's going to be that same term to 1 power less, a to the 4th. Then a to the 3rd, then a squared, then a, and I'll go ahead and write it in, but you don't have to write this. A to the 0, anything to the 0 power is 1, so it's technically not there. And then to get the other term, we start with the opposite direction. We start with this term, and we're going to start with the same exponent that we ended with over here, which is 0. So I have b to the 0, and then b to the 1st, and b squared, b cubed, b to the fourth, and b to the fifth. And if you realize, make an observation, if it's of 0 power, you don't have to put that term. So some people don't even write that because, whoops, sorry about that. So you technically don't have to write that 0, but no, let's and these are positive, and all these are positive, so I have a plus sign in between here. I guess I could have done that in a different color. But now, we can now write what this would be in expanded form for a plus b to the fifth is going to be 1a to the fifth, which is just a to the fifth, plus 5a to the fourth b to the first, which is just 5a to the fourth b. And now we have positive 10 a cubed b squared. And now we have a positive 10 a squared b cubed. Oops, my pen drug on that one, so let me erase that. A squared b cubed. And then we have 5ab to the fourth, positive 5ab to the fourth. And then the last term, you don't have to put an a to anything to the 0 power, and you don't have to put a 1, so it's just plus b to the fifth. That's how you can use Pascal's triangle to find any term. If we asked what was the second term, we could actually figure out what that was. On your assignment, we'll ask things like, what would be the coefficient of the third term? Well, that'd be a 10 on this row. So let's practice that a little. Let's try it on the next one. Number 7, x plus 3 to the third. That word means we're looking at row 3, which is technically the 4th row down, because remember we start with row 0. So row 3 is this row. So I don't need that. So if you look at just the coefficients are going to be 1, 3, 3, and 1. So 1, 3, 3, and 1. Now, I'm going to write those coefficients. So this is going to be 1, and I'm going to leave some space here. 3, 3. I'm going to write really big on this one, give myself plenty of room. Now, I start with this first term, which is x. So that x gets this power, 3. Then you go down 1 power each time. So x squared, x, and then no x. And now I look at the other one. This one's a 3. Well, over here, that's going to be 3 to that power, 3 to 1 power less, 3 to 1 power less, and then this one's 3 to the 0, so you actually don't even have to put it, but you could. And all of those were positive, so there's a plus between each one. Now let's just rewrite that a little neater. So this is x cubed plus 3 times x squared times 3 to the first is 9x squared. And then this one is 3 squared is 9 times 3 is 27x. And then 1 times 3 cubed is just 1 times 27, or 27. So x cubed plus 9x squared plus 27x plus 27. Now let's do the same thing, but with a slightly harder version. So we're still going to do the same row. I was nice to you and only did row 3 on this one. So row 3 is still 1, 3, 3, and 1. So 1, 3, 3, and 1. And now the first term is going to be a 3x, and that gets cubed. Then we get a 3x squared, and then a 3x to the first, and then a 3x to the 0, and I'm not even going to put to the 0. And now the second term had a negative, unlike me when I made out my notes and was practicing, I forgot my negative sign, a negative 4y. So this one's going to have a negative 4y to the third power. This one I have a negative 4y to the second power, a negative 4y to the first power, and then we don't have to put a negative 4y to the 0 power, or you don't even have to write it. So let's just put pluses between all these, and now let's clean it up. So to clean this one up, 3 times 3 times 3, because both the 3 and the x are cubed, would be 27x cubed. Well, this one is 3 squared is 9 times 3 is 27 times 4. 27 times 4 is 7 times 4 is 28. Carry the 2, 108. So, and it's a negative 108 x squared y. And now on this one, I've got 16, which will be positive, times 9. So let's do 16 times 9. 9 times 6 is 54. Carry the 5. 9 plus 5 is 144. So this is a positive 144, and we have 1x and 2 y's, so xy squared. And a negative cubed will be negative, and that's just y cubed. So we end up with 27x cubed minus 108x squared y plus 144xy squared minus, oh, I forgot my cube on the 4. That's a 64. 4 cubed is 64. So I'm glad I double checked myself. Hopefully you weren't yelling at the computer screen going, you forgot the 64. Okay, last one, we are going to do the 4th row. So I'm going to scroll back up here. The 4th row, or the 4th power row, which is actually the 5th row down. Oops, I wasn't even touching the screen. We have 1, 4, 6, 4, and 1. 1, 4, 6, 4, and 1. So I'm going to write those numbers down, and I'm going to give myself a room here. So 1, 4, 6, 4, and 1. And now we look at this first term, which is x squared. X squared gets us 4th power. Now we take that same term and drop a power. Same term, drop a power. Same term, drop a power, which is 1, and there should be a 0 here, which means we don't have to write it to the 0 power. And then I'm going to put a plus sign between each of these so I have room for my pluses. Let's start at, this one's 2 to the 4th is at this end, so I'm going to go ahead and start over here and work backwards. 2 to the 4th, 2 to the 3rd, 2 squared, 2, and 2 to the 0 you don't have to write. So now comes our cleaning it up step. So 1 times x squared to the 4th, what power to a power we multiply, so that is x to the 8th power. This one is 4 times 2 is 8, so a positive 8. And we have x squared cubed is 2 times 3 is x to the 6th power. And now we have 6 times 2 squared, which is 6 times 4, which is positive 24. And that's x squared squared, so x to the 4th. And this one we have 2 cubed is 8 times 4 is 32. And then x squared. And then finally 2 to the 4th is 16. So we end up with x to the 8th plus 8x to the 6th plus 24x squared plus, no, 24x to the 4th, sorry, plus 32x squared plus 16. I wrote it right, I just said it wrong. So that would now get it to where if we asked for any specific term, you could find that term very easily, but that's all you need to know for this assignment. Good luck to you.